Hello and welcome to the IoT Central Roundtable. My name is David O'Hara and I'm the Managing Director at IoT Central. I'll introduce our host and panelists in just a moment. Attendee questions will be answered throughout the event and during the panel discussion after the presentations. We welcome you to submit questions in the control panel. Today's event is entitled Advancing IoT from Cloud to Edge. Let me thank ARM as our host sponsor and panelists from CircleCI, PTC, and SpinDance. Now for today's panelists. Angel Rivera is the Senior Developer Advocate at CircleCI. He started his career as a U.S. Air Force Space Systems Operations Specialist, where he realized his passion for technology and software development. His technical experience includes military space lift operations, software development, SRE DevOps engineering, and more. Stephen Sponseller is the Kepware Channel and Business Development Director, Americas at PTC. He started with Kepware to grow their oil and gas business and now leads a team that focuses on Kepware's multiple channel programs. He has worked in the manufacturing, computer software, industrial automation, and information technology industries. Brian Toll is the Vice President of Engineering at SpinDance. He is a full-stack IoT architect with over 20 years of experience solving complex business and technology problems, with a background including software architecture, business strategy, business development, and user experience design. I'd like to introduce today's host. Robert Wolff is Manager, Ecosystem Developer Evangelist at ARM. He's a technical writer, open source evangelist, community leader, and studied engineer with a history of working in and around esteemed academic institutions and STEAM-based educational programs. He helps maintain several open source repositories, runs a global Discord server with thousands of developers, and moderates the ARM Software Dev Twitter channel. Now for the host of the weekly live stream Innovation Coffee, Robert, take it away.
Thank you very much, David, for the introduction. And on behalf of myself, ARM, and IoT Central, I'd like to welcome all of the viewers and, of course, our guests who will be joining us very shortly. This is actually the third roundtable I've hosted here at IoT Central. And if you've been following along, we usually start this off with a little fun introduction and breakdown before jumping into the featured segment. So here we go. We're here to talk about the growing user demand for edge computing and why a cloud-only world will no longer be sufficient. Of course, our guests will elaborate further on this, but let's take a little history lesson to start. Not too long ago, about 70%, even more, of all data streamed out from the cloud. Streaming services like Netflix, which started in 1997, YouTube, which started in 2005, and the likes, made up a big part of this data stream. Of course, data found its way to the cloud as well, but it was in a much smaller fraction than what was streamed out to the devices around the world. So what's changed since this time about 15, 20 years ago? Well, devices at the edge have become more compute capable. In fact, every endpoint has gotten a huge increase in compute power and overall capabilities, of course. And with this comes enablement for new and exciting use cases that can take advantage of this new compute power. What do these new use cases do, you may ask? Well, they collect and create data, among many other things, of course. This of everything you can think about, from videos to pictures, sensor and distribution networks, all of this is happening at the edge, generating data and streaming it back up to the cloud. But is all this data really useful? Do we really need to backhaul everything into the cloud, or can some of this be done at the edge? Can some of this be filtered at the edge before sending it off site? With so much compute now at our fingertips, the possibilities seem endless, and for every good solution, there's a developer out there who will of course find the next problem to solve. Now, I hope you enjoyed today's webinar. Once again, I'm Robert Wolff, and it's time to meet our first guest. So Angel Rivera joining us from Jersey. Angel, how you doing?
Great, Robert. How about yourself?
Great, thank you so much. And welcome to IoT Central Roundtable. So I understand you have a presentation to share with us. We look forward to hearing your take on today's subject. So if you want to go
Yeah,
ahead
I do.
and share that.
Sure. Let me grab my screen. Let's see. There you go. Are you seeing that? All right, awesome. Yeah. So thanks, Robert, for having me. Yeah, I'm super excited to talk about CI/CD for IoT and ARM architectures. So yeah, let's jump in. Sorry, a little difficulty here. There we go. Okay. So before we get in, my name is Angel Rivera. I'm a senior developer advocate for CircleCI, and if anyone wants to reach out to me after this presentation, just hit me up on my Twitter handle. It's the easiest way to get a hold of me, and I'm excited to speak to anyone and everyone about technology, IoT, and ARM.
And
So
real quick,
yeah.
Angel, also, just to remind everyone who's watching, we do have 3 amazing guests that will be popping up here. Feel free to drop questions inside the webinar chat there, and we will bring those questions to our guests either right after their segment or during the Q&A section after the main 3 segments. So yeah, sorry, take it away, Angel.
Yeah. Ask all those questions. I'm super down to answer what I can, and I'm sure the other panelists are as well. So yeah, so let's talk about ARM architectures. I mean, we know ARM has been around for quite some time, right? This isn't anything new. This hardware, these processors are really popular amongst the mobile space for the most part, and that's the reason for that is because most of the devices are battery powered, right? So they're not continuously plugged in to a power source and able to maintain the energy it needs to operate, especially when they're on battery. So the processor is one of the most power consuming pieces of any of these devices. But ARM powered devices again are super popular because of their minimal power consumption, and they're actually very useful for applications where you need to deploy hardware in a device that is battery powered, right? So in this example, I want to talk about IoT sensors and the infrastructures. And as Robert alluded to at the beginning, there's a lot of stuff going on, but this is more of a traditional view of an IoT like sensor that potentially has some sort of connectivity. So you're probably talking about cellular or LoRaWAN, right? In this case. But at the end of the day, what I'm trying to illustrate here is you have, pretty much a couple of components that are going on. You need to have power, obviously, for that sensor to work, right? You also need a connectivity. You also need some back-end infrastructure to process all that data, right, from your moisture sensors. Now imagine if this sensor was 1,000 sensors in a farm somewhere. As you can see, there's a lot of like bottlenecks and gotchas when you deploy things like this. Again, right, the battery power and signal is very important, but also the amount of data that you're pushing or chirping out of those sensors, right? So enter, solving some of those problems with power and signals and getting information to and from these devices. Enter edge capable servers or devices, right? Generally, edge devices are located pretty much physically located pretty much very close to those sensors. The reason is you want to maintain a low latency level, right, between the edge service and device and those sensors. And those edge servers or devices are really useful for helping to process data, as Robert was talking about earlier, right? The compute is actually becoming very powerful and more compact and able to be deployed in smaller form factors such as these IoT edge devices. But at the end of the day, they're solving a couple things, right? So if that sensor needs an update, you can push from your infrastructure right to that edge device, maybe an update, and then you can do an over-the-air kind of update to those devices. You can solve problems like data, right? So if there is an immediate need for water from an irrigation system, right, that moisture sensor can send the data. The edge server or device detects a threshold that's been probably met or not met but exceeded, which means turn on an irrigation system and water the field. So right, the edge server can serve as like an immediate real-time kind of processing and command and control for those devices, as well as backhauling that information later to an infrastructure through the cloud, right? So again, right, edge services are really, really helpful for basically command and control situations and monitoring, right? All those things that you can get from the cloud itself as well, but again, keeping it really close to the sensors and the data is really important for processing that data, especially if you have real-time constraints. So as I spoke to this earlier, ARM is powering these edge devices. I'm sure there are other processors that are doing the same thing, but as I mentioned earlier, ARM appears to be the weapon of choice due to the speed and the power consumption that it uses. So with edge applications, right? So the devices have edge applications or applications on them, and in prior, I would say in prior years, running CI/CD or continuous delivery pipelines on IoT device type applications, like I'm talking about the sensor specifically, is really difficult because of emulation. But now that you have this edge capability, you still have a device that needs a service or an application to run. So those specific applications for the edge devices actually need to be run through your CI/CD pipelines or your continuous delivery release cycles, because it's part of your stack, right? Previous to that, it was not really even thought of, I think, right, for this type of application development or application build to happen within CI/CD. But now with these edge IoT devices that need these applications, it's even more important, right, to run those applications through the pipeline. So as I mentioned earlier, right, ARM and x86 aren't compatible. The reason is the instruction sets, right, are different. But when we build these ARM compatible applications, it's much more easier now, especially with CircleCI, because we now have native ARM resource classes. So what's happening here is when you run a CI/CD pipeline, you're essentially running them on ARM hardware, right, within CircleCI's infrastructure. We call those executors because they're executing the code and the commands for your CI/CD pipeline. And what I'm showing you here is kind of a little display from my dashboard on CircleCI that shows that we have ARM capable resources for the developers now to be able to build those edge applications, right, on top of an ARM hardware without having to emulate anything, which is really nice because you get that native feel and that native result back, right, from your testing and your pipelines. Again, CircleCI has the ARM capabilities, which is really popular in the IoT space, and you can easily implement, right, your build, test, and deploy operations within that system. And that's all I have, Robert. So thank you very much.
Awesome. Yeah, Angel, this was a great presentation. I'm actually curious. I have a question here for you, and there were a couple that popped up in the chat. But when talking about CI/CD, CircleCI, and I'm kind of curious, like, what are some of the benefits of building and deploying? So building on a server, right, or building in the cloud and deploying to an IoT device. So you have CircleCI, you have these ARM instances that you can now get, and you have ARM devices at the edge or at your endpoint. What are these benefits? What are some of the benefits that you might be able to outline to people for building in the cloud on ARM for an ARM device at the edge?
Yeah, right. So with those edge devices, like I said earlier, right, you have an application that is actually running on that device and in control of or potentially interfacing your sensors. Yeah, so running those CI/CD pipelines, integrating testing, primarily testing and securing the application, like those edge devices, is really important these days, especially because they may be in some field somewhere, right? And security isn't probably that tight. But at the end of the day, you want your application to be tested, right? You don't want to deploy untested code. Like I said, prior to us having these capabilities for ARM developers, it was, you could do it, but there was a lot more involved. But at the end of the day, the fact that you can take those IoT related bits of your stack, you can now integrate them into your if you have a full pipeline for your stack, now you can augment that with IoT specific pipeline jobs, right? So basically, like I said, maybe building an artifact, like a Docker image, testing your code, and then also securing it, right? Running some compliancy type tests on it. Whatever you can imagine you do manually, now you can actually implement that on the CircleCI platform. So I hope that answers the question.
Yeah, no, that's great. That's great. Yeah, thanks, Angel. We'll bring you back in for the Q&A section. I want to add also another really great benefit, of being able to do this stuff in the cloud for an IoT device could be eliminating the whole cross compilation aspect. I mean, if you're building on ARM
Right.
for ARM, that's also pretty cool. So
right.
Yeah, awesome.
Yeah,
thank you, Angel.
Right.
Thank you, Angel. Angel from CircleCI is great. All right, so on to our next guest, joining us from the most northeastern state of the United States. I didn't know that until I looked it up this morning. We have Steve Sponseller from Maine. All right, and this is our Senior Director, Business Development of America's channel for Kepware at PTC. Welcome to the IoT Roundtable, IoT Central Roundtable. Steve, how you doing?
Good, Robert. Can you hear me all right?
Can hear you just fine.
Okay.
Yeah.
I'll take it away.
Cool.
Thanks for the introduction, and thanks for all the attendees. Angel, great session, and I think I'm going to more or less pick up kind of where you left off a little bit. So we're going to talk about control and monitoring at the edge. And when I mean the edge, I mean I'm truly talking about the edge, the end of the network, at the oil and gas site or the mining site or even at the line in a manufacturing plant. And what kind of challenges we have there. So real quick, to make this all relevant, I'm going to give you a quick elevator pitch on what Kepware does. The company I work for that is now part of PTC. We are the least sexiest part of an overall IoT digital transformation solution. We are middleware, interfacing software, but without it, it's foundational, and without it, it doesn't really matter what the sexy stuff does, because we actually open up the data that's trapped in the automation equipment on a factory floor, or like I said, out on a manufacturing plant, or any type of industrial operation. So the automation equipment is being run by something called PLCs, programming logic controllers. And those are made by companies like Rockwell, Siemens, General Electric, Mitsubishi, and a whole bunch of other ones. And guess what? If you want to talk to those machines or talk to that equipment and extract data from them, you have to speak their language. And of course, they all have proprietary languages designed on purpose like that at first, back in the day. And so we basically are a driver company. And so just like when you take your Dell computer and you download the HP software to communicate to your printer, your HP printer, that is basically what we are, but for industrial equipment. So for that Rockwell PLC or that Siemens PLC, we have all these different drivers that allow you to communicate to these pieces of industrial equipment on your manufacturing floor. So we sit in the middle between what's going on there on the factory floor, and then all the sexy stuff that's up in, either on premises like SCADA to monitor your plant operations, or even sending data into the cloud so that you can do overall enterprise analytics, understand what's going on across your company, sending it to applications, of course, like ThingWorx, which is another PTC product. But that is essentially what Kepware does. We translate the data from your factory floor into protocols or standards that the applications north of us understand. And we are located in Portland, Maine. So I'm not actually in the office today, but I would be in normal times, right in downtown Portland, Maine. We've been in business since 1995, and this is the only thing we focus on. We have about 130 people solely focused on industrial communications, and they take a lot of pride in the quality experience you get when trying to speak to those black boxes on your floor. So when we talk about like truly going to the edge, we've been around since 95. So in some terms, we've always been at the edge. Our server's always in a server closet in a factory communicating to pieces of equipment on the floor. I'm going to give you another example in oil and gas here in the next slide. But essentially, when we're talking about like being embedded in those type of devices that Angel was showing you on his screen, we need to be a smaller application and running oftentimes in a Linux operating system as opposed to Windows, is what we traditionally have done. So the first two markets that expressed interest in truly going to the edge are machine builders who are providing a machine as a service. So they want to be able to remotely monitor to be able to better service their equipment. People are now leasing instead of buying in some cases. They just want to make sure they have 99% uptime, and that's what these vendors are providing by being able to all the time monitoring their equipment. And then in oil and gas, well, let's just go ahead and jump to my next slide because that'll give you a great idea as to why that industry is especially interested in being able to do that protocol translation at the edge. So similar to that previous slide that I showed you, but for oil and gas, you have multiple different types of equipment out at a well site. You have like the iconic pump jack that's going up and down and sucking the oil to ground. You have, a Rockwell or the Siemens or whatever brand PLC that's opening and closing valves. And then you also have what's called a flow computer that's taking measurement of how much, gas or oil is coming out of the ground. And because, like Angel was mentioning, these are out in the middle of nowhere. It's not like these sites are connected 100% of the time. In fact, they're often connected through radio networks or cellular networks or even satellites. So much different than the fiber that might be throughout a plant. And then back in Houston or wherever oil and gas central operations are, you would have what's called a polling engine or an OPC server that has all these protocols like I was just mentioning about, that's doing, and it's going out and it's polling these individual devices one at a time, asking for data of certain register, certain data points, and what's the temperature, what's the pressure, what's the, the water sensor value that Angel was talking about. And when you're talking about, possibly hundreds or thousands of these well sites, that's a lot of back and forth communication. And it's done using protocols that are 20 years old, that cybersecurity wasn't a thing, so they're not very secure in their communications. And then once we get the data, we provide it, like I mentioned, SCADA, if you know that type of terminology in the OT world, the operations world, that data might be getting stored in the historian. The measurement data from that flow computer might be going to a back-end measurement and gas balancing application. And then if you wanted to get that data into the cloud, into Azure, AWS, Google, what have you, you had to do some special programming in order to get it there. So some of the challenges of this is this inefficient back and forth poll response mechanism that these protocols support. That you're asking a question and sometimes that value, that data maybe didn't even change. Like the water moisture is the same, but I had to ask the question to find that out. And that's kind of like a wasted communication going across a pretty, anemic network. We're talking about these wireless networks. And so you're eating up a lot of bandwidth where, if we want to move into like machine learning and really cool advanced analytics and all that, we're going to need more data, and we're barely able to get the data for SCADA operations today. So that poll response is not going to cut it. I mentioned that these protocols are insecure, so prime opportunity for man-in-the-middle attacks in between that, and within the network here. If the network goes down because of weather, and guess what, it happens. I've heard stories even of like moose in Canada getting into your network and affecting things. So that's always possible. What happens to the data when the network's down? So you want to be able to account for that. And then that inefficient polling back and forth is really becoming expensive too. Like I said, we're going to need to collect a lot more frequent data for all the wonderful things IoT brings to the table. That's going to really run up the bill. And when we're talking oil and gas, like I said, hundreds, if not thousands of these sites, that is a lot of back and forth going, like I said, going across these anemic networks. So what is going to the edge means? It means in this oil and gas example of taking that polling engine and pushing that data collection instead to be out at the well site itself. So, AJ was talking about, smaller form factor devices. That's exactly what we're talking about here in this black box that has the Kepware logo on it. So now Kepware, instead of being one big server in Houston, it's being distributed to be out at a little mini Kep server at each well site that's doing that local protocol translation. So it can do that poll response back and forth very easily because it's on the local area network right there, which is also secure. Now you're not doing those insecure type protocols going across your network, and it's like able to use a publish subscribe instead of poll response type mechanism for communications as well. So what that allows for then is don't call me, I'll call you. So now you're only sending data changes across the network instead of just back and forth just to find out that maybe the data point hasn't changed. So now you're just, I'll call you, I'll send a data update across the network when I have one using more modern, more secure type protocols like MQTT or OPCUA, if people are familiar with that type of terminology. So that is what we're considering going to the edge. Like I said, going from the server closet in Houston to being actually out at the well site. There's a lot that's going to go with that. Here's like the specific product we have, ThingWorx Kepware Edge. I mentioned removing the Windows dependency, so now we can run in a Linux environment. Angel had some examples or showing where containers can greatly simplify the deployment. When we're talking about deploying hundreds of these servers, you're not going to want to have to like individually go into each one and have to do a typical installation and configuration. Containers can bring a lot to the table to help with that. And then an example with the full shebang with Azure as an example where they have their IoT edge applications that run at the edge and in one of these mini compute boxes. And so the Kepware Edge software along with Azure IoT Edge software along with any other type of perhaps like local analytics software could be used on that box. And then Azure taking it from there and bringing it actually into Azure in the cloud to do all the wonderful things up there as well. So just in the interest of time, I know I'm probably running over at this point, but I want to close with why aren't we already there? What's taking so long with making this happen? For one thing, I think a lot of companies, they don't know who to believe or who to go with. There's a lot of bits and pieces that go into the overall solution stack with this. I think things are still kind of settling out, but I believe they're heading in the right direction, obviously, and with more and more use cases and examples of people having success, that we'll get up that curve, that adoption curve. The cost, to save money, you have to spend money. And certainly when we're talking about this massive deployment of edge devices across an entire enterprise, that's not cheap, obviously. And it's very complicated, wrought with all kinds of ways for things to go wrong. So there's cost and risk concerns with that as well. And then proving value. Again, like once the use cases are out there and more success stories, I think that's one of the easier hurdles to get across to justify the massive cost and deployment that you'd have to go to. But like with anything, I recommend baby steps. Start with something in the lab, obviously, and then work your way up to an actual field, and then you learn along the way, obviously, so that when you truly come time to scale it out, you more or less know what you're doing. What are we doing? We're starting a Edge Partner program. This is an example, taking a shot taken from our website of companies that we're starting to work with. There's more on the deck that's coming on board once we get the paperwork signed and everything. But trying to ease those concerns out there the customers have of new software, new hardware. Geez, how can I make sure that these two things are going to work together? So we have a new hardware partner program to help alleviate those concerns. And with that, I'll close it out. Thanks again for having me and look forward to your questions.
Awesome, Steve. Thank you so much. That was a great presentation. And I do feel it kind of was like a perfect segue from Angel. So
yeah, I agree.
Perfect. I do have a question for you here. So I'm curious, you did mention that Kepware provides the firmware for a lot of these kind of on-premise devices. I'm wondering, do customers have the bandwidth or expertise to strategize, build, and deploy an edge IoT solution? Now, I want to kind of give a little bit of a more rounded question here. Do they have the bandwidth expertise to strategize, build, and deploy? But I'm also kind of curious, you know, how much would they have to put in to actually build the stuff that you're providing them? Because I mean, you're giving them this firmware. I come from an open source background, and I know that there are open source engineers out there writing drivers and firmware and pushing stuff out there. I'd imagine that, you know, your secret sauce is pretty valuable.
Yeah, so Kepware makes the protocol translation extremely easy. And that's why we've been in business for this long, and that's why we have a great brand recognition, because we've taken a lot of that messy, no one likes to get stuck doing that protocol translation part. And when you do it, when you DIY, when you do it yourself, so we take that, we offload that burden. But then there's the whole other burden of the, again, like this massive deployment, making sure that you have no regret use cases. I've heard people in our company, like where you just know for sure that you're going to get the biggest bang for your buck. Well, people don't really know what these are, and they don't know deployment strategies. And I think the heart of that question really is that no, customers are not and should not be out there on their own trying to get through this journey. There are experts out there. There's what we call global system integrators, GSIs. There's local integrators who know the plants. They've been working in those plants their whole career. But then there's the global system integrators that come, like the Accenture and Deloitte's of the world that have been through these rodeos. They know, like I said, these no regret use cases. They can come in there and as easy as possible get you to a solution that we're showing value. So highly recommend working with partners in the ecosystem out there.
Awesome. Thank you very much for the answer there. And we do have some more questions for you. So we'll take
right.
those. We'll hold on to them until the Q&A section. But for the time being, Steve, thank you so much. We're going to transition into our next guest. Joining us from Michigan in the Great Lakes, we have Brian Toll, VP of Engineering at SpinDance. Hello, Brian. Are you there?
How you doing?
Hey, there he is. All right, cool. Great. Thank you. Welcome to IoT Central Roundtable here. And you're up. Let's see what you let's see what you got going on with SpinDance.
Wonderful. Well, so glad to be here. Yeah, I'm the VP at SpinDance. We're a software consultancy focused on helping organizations maximize IoT. And just a little bit about us. We are based in West Michigan, but we've got engineers across the country. We work with Fortune 500 companies, startups, everybody in between. Put some of our customers up on the slide here. We're really passionate about helping our customers adopt and ultimately be successful with IoT. And we've built a set of services to really help organizations do that. So we do training and coaching to help people understand and adopt IoT and really understand software. A lot of the groups we work with are very good at non-software things, and adopting software can be a challenge. We do consulting. Like I said, we're really passionate about helping people figure out the right use cases and then really maximize those. We help out with system designs. So really doing the architecture end to end. We really strongly feel that every successful IoT solution has a really solid system design behind it. So we love doing that. We think it's really important. We do software development. I'll talk a little bit more about that in the next slide. And we also provide maintenance services. So after we build it, we can help our customers make sure it's up and running. So one thing that's a little bit unique about SpinDance is we're really building out a full stack IoT consultancy. So we have all the software skills that you might need for a IoT solution all under one roof. So we do embedded, we do cloud, mobile, voice, web, ML. And not only do we have all those skills, but we do a lot of cross training. So our engineers, for example, we might have a really gifted embedded engineer, and he's also pretty good at mobile, or a cloud guy that also knows ML. And we do that because we think that produces a better end result. And ultimately, it reduces risk, gets you to market faster, and it just produces a better project. So I didn't want to talk too much about SpinDance. I'd rather talk about some of the edge and the cloud things that we've done. And so I picked kind of 3 little mini case studies here, and then I'll end with some of the lessons that we've learned from projects like this. And I intentionally stay away from industrial projects because oftentimes we think edge is only there, but it's really a general pattern that can be used in a lot of different spots. So I wanted to start with a product from a medical company here in West Michigan called Skytron, and they have a lens product, they call it, which is a real-time location system. So essentially, patients and staff, support staff, can carry a little badge around, and that provides real-time location data on where they're at in the facility. And you can also add these tags to equipment. One of my favorite stories is we heard that a nurse had their favorite EKG machine and they stored it in a closet. Well, that's not where you want an EKG machine. So this type of product helps you identify in real time where those pieces of equipment are. What's important for the edge story here is that you really can't do all that in the cloud. You're really, for performance and security and a lot of other reasons, you want to do all that locally. And we applied a couple other cool things. We use an actor model here, so we can do patient-nurse interaction tracking, so we can understand how much time a nurse is spending with an individual patient. And then, though, that's really valuable data. So we end up scrubbing that data, and it can go up into the cloud, where a hospital administrator can look at all those patient outcomes, correlate it back with this Rtls data, and understand, are we hitting the marks that we set out for. It also does some cool stuff. If somebody tries to steal a piece of equipment, which happens more often than you think, we can alert security in real time and recover those assets. So that's just one quick example. The second one I want to talk about here is the Great Lakes Observing System, otherwise known as GLOS. And they're one of 12 regional authorities in the country that are tasked with kind of understanding the nation's watershed. So they're in the Great Lakes. They have equivalent organizations in the Gulf and the West Coast, the East Coast, Hawaii, and Alaska. And they're really seeing the future of all this data. They want to democratize it and move it in the hands of the general public. So today there's about 70 buoys and other devices out in the Great Lakes. Some of these devices are like gliders that go over under the water for a long period of time and then come up and kind of notify the cloud over cellular or LoRa. But they imagine and they envision thousands of these devices being distributed in the Great Lakes over the next couple of years. So they're building out a new platform to take all this edge data. There's dozens of sensors on these buoys connected to typically like a Linux device of some sort. And that edge data is pushed into the cloud where we can do real-time analytics on it. And the idea being that maybe you're a fisherman, you want to have your favorite spot in the lake, you can set up a notification, and then you would, when the water is the right temperature, 5 meters down, you would get a SMS, you get an email, you get a push notification to your phone, and you know that it's time to go out and fish. So that's an example of how you can leverage embedded and edge and cloud to make this all happen. So the third case study I want to talk about here is a startup. They're coming out of Michigan State University, and they're called Motion Grazer AI. And this is a edge solution to help farmers understand the performance of the farm and the well-being of livestock. So they have a very interesting and very complex, we don't have time to go into it, solution for using computer vision to understand the health of pigs. So on the edge, we have the camera set up, we have all the machine learning models, all the proprietary models that they have there, analyzing these pigs as they kind of move through a hallway. After that analysis is done on the edge, that all gets moved up to the cloud so that the farmer can understand down to the individual pig how the pigs are growing and progressing. Are there some issues that should be addressed with? And they can correlate that then with the rest of the performance of the livestock. So those were just 3 quick examples of how edge is really being used in a lot of different industries successfully. I wanted to kind of talk about some of the technical lessons that we've learned, and then finally some of the business lessons really quickly. So first and foremost, edge is not mini cloud. Very, very different things. We have, as you've heard already, deployment issues, security issues. There's a lot of nuance in pushing things to the edge. But that said, a lot of the best practices are applicable. So for example, absolutely use CI/CD best practices to test and deploy your edge software. containers are really growing on the edge. Secondly, you really need to adopt a zero trust security model. Basically what that means is none of the devices trust each other, down to the point where the software running on an edge device doesn't naturally trust the other software. That's really the only way we're going to get to the point where we have a truly secure IoT infrastructure and system. Third, these next 2 points are a little nerdy, but they're really, really important. You really need to adopt an event-driven architecture for the edge of the cloud. So when you're moving high volumes of data, when you're dealing with systems that are offline for a long period of time, an event-driven architecture is just a natural way for dealing with those situations, and it just makes things move a lot quicker. Fourth, it's important to understand that embedded and cloud and IoT systems in general are really just examples of distributed computing. And the good news about that is, like, computer scientists have been building those types of systems for decades. So we really need to go back to all the lessons that we've learned in the 70s and the 80s and 90s and apply that to IoT. And one of those major takeaways is applying functional programming principles, not necessarily functional languages like Lisp or Haskell, but those principles of dealing with data in a immutable way. Makes things much, much simpler if you can apply those. And then finally, TinyML and Edge ML are still new, but they're very, very doable. But don't be surprised if you need to augment them with cloud solutions. There's a lot of architectural details in there, and you definitely can't take necessarily a machine learning model for the cloud and just deploy it down to a small microcontroller. A couple of business lessons that we've kind of learned. First and foremost, you need to apply or explore different topologies. Architects tend to gravitate towards what they know. You know, it's like if you have a hammer, everything looks like a nail. So you want to be able to build a team of experts and explore different topologies, because Edge might be perfect, it might not be perfect. So you want to be able to explore that before you kind of commit to production. And again, this kind of mirrors what you've heard already too from everybody. Bake security requirements in from the beginning. You cannot add security after the fact. It's not a coat of paint that you just get to add before you ship it. And then finally, justify the data that you are trying to collect. We see a lot of people just collect everything and never really have a plan for it. And that's just a horrible way to go about things, because you're just wasting money and potentially creating a lot of security vulnerabilities at the same time. So you don't just need a technical proof of concept, you really need kind of a business-centric proof of value. And if you do that, if you do the legwork, you end up with a plan that's justifiable, and it's much easier for everybody to understand and get behind it. So again, great to be here. Thanks for the time.
Brian, awesome. Thank you so much. I thought this was a great presentation. So I have a little story here, but I really liked the example you used for the hospital and the nurse who was hiding the machine. I remember when I was younger at the school library, right, when we all used to go check out books, it's kind of like the equivalent of finding that one copy, but I'm not ready to check it out yet. So I go hide it somewhere else because I want it later, and I don't want anyone else to find it where it's supposed to be. So yeah, that's great. One of the questions I have for you, because you did kind of touch on this other example with the Great Lakes and all these buoys that you have going out there, I'm curious, what's the hardware that you're using in these buoys?
Yeah, that's a great question. So I was really shocked as we got into this, how much they pack into those buoys. There's dozens, if not more, sensors. Usually those are low-powered microcontrollers, ARM-based, low-power, M0, M4, something like that. And then typically there's some sort of hardened Unix, usually Linux of some sort, that's running in the data collector. So you can run primitive scripts on most of these things, and a lot of them you can run Python or C++ apps or something much more robust.
Very nice. All right, so we're going to transition into the Q&A section here. Thank you for removing that screen share. I'm not sure if we're going to put something else up here, but I have collected some questions from our guests. I have some questions myself, I should say questions from our viewers, and I have some questions myself that I would like to ask. So I'm going to call on you. Some questions might be for everyone, and we'll just kind of do a round table, but I'll call on you and we'll get this going. So we'll start with you, Angel, since you've been sitting there so patiently since the beginning. I'm curious, we talked about CI/CD, CircleCI, and the continuous deployment. What would be the process for getting apps deployed to an edge device using CircleCI?
Yeah, so I mean, depending on, I mean, I would assume that you would have some sort of, deployment infrastructure, uh, and I would assume that that would look like, depending on the protocol, right? So you would have this infrastructure that would essentially just be there to start handing off, updates to devices. A lot of them use over-the-air OTA in the cases of like cellular or just like your phone, right? Or LoRaWAN, same concept. Although LoRaWAN does try to encrypt, right? That it does have a security protocol kind of baked in. But at the end of the day, with CI/CD, if you have a deployment process, right, you could build a job that just literally connects and pushes that built artifact. In this case, or in most cases, what I'm seeing now, Docker images being built, right? So these applications are wrapped in a Docker image and then pushed either to a repository of some sort, and then the OTA or the updating system will take that image, right, based off of whatever criteria. So, depending on CI/CD, the continuous delivery pipeline doesn't really matter, right? At the end of your pipeline, when you have everything fully baked and ready for deployment, you choose whatever you want, right? Especially with CircleCI, we really don't care what systems you're using per se, because we allow you to use all the systems, right? We try to give as much flexibility to developers and DevOps folks so that they don't have to be encumbered, right? With like, oh, how do I deploy this to whatever system? And in most cases, we just supply an orb, which is kind of pre-baked functionality for your CI/CD pipeline. So again, depending on the situation, and I worked in the IoT space before. I've seen so many different, patterns out there. And Steve and Brian, your presentations kind of brought back some of those war stories and those memories, flashbacks from those days. But it is improving, and it's doing slowly, right? It's coming slowly.
So I guess the short answer is kind of however you want. Deploy
Yeah,
apps
yeah.
to
So right.
an IoT device however you want.
Right, deployments are right. So the target environments are always different.
Yeah.
But yeah, if you have any questions, just reach out to me and I'll see if I can help you out.
Yeah, and for those of you who aren't familiar, OTA means over the air. So yeah, over the air, any way you want, over the air, Bluetooth, Wi-Fi. Cool, awesome. So let's move to the next one. This one comes from one of our viewers here, and it's for you, Stephen. Let's see. Can Kepware serve as a 100% MQTT broker?
Kepware is not a broker. So we send data to a broker.
Okay,
so
I think that
we are
yeah,
100% not a broker.
Yeah, so then that's that. There you go. I hope that answers your question for our viewer that brought that one to us. Let me highlight this one so we don't accidentally ask it again. All right, now let's move on to you, Brian. We have a good one here also from one of our viewers. Is this RTLS? And I believe this was when you were talking about the buoy. I can't remember exactly when this popped up, but it was during.
RTLS would have been for the medical example.
There you go. So the question is this RTLS, and stands for real-time location services, indoor and outdoors?
This is only indoors. You can kind of think of it as asset tracking for a hospital. So there's a number of different physical protocols that are used, Bluetooth, infrared. It really can go on, but there's typically multiple data collectors throughout the building. Actually, if you go into a hospital, you can see them. They look like really large fire detectors or smoke detectors. And that's how they're collecting the data off the devices. And the reason for that is, you can imagine if you're wearing a badge all day long, you don't have a really big battery. So that's to really maximize the power usage at the device level.
Awesome. Thank you, Brian. And to the viewer who asked that, I hope that answers your question there. Back to you, Angel. I have another question, and this is from one of our viewers specifically to you. Does Angel use native ARM compilers self-hosted on ARM or some other compiler toolchain? I think they're just curious about your general work
Oh
work
yeah, yeah.
environment.
So I use right now I use the CircleCI resource classes, the ARM resource classes. But prior to that, yeah, I have just in this little store here, I have a little lab that runs a couple things, a couple servers, and yeah, some of my a wide range of LoRaWAN type devices. So yes, I am using both physical and virtual cloud resources.
Great,
That
thanks.
answers your
Yeah.
questions, I hope.
People want to know your personal setup here.
Yeah. Tweet at me. I'll show you the goods.
Punk Data at Punk Data. All right, here's one for everyone, and we'll kind of do a little roundtable here, starting with you, Steve. What is the best way to handle, and this is a pretty vague question, but what is the best way to handle edge to cloud, the edge to cloud data storage challenge? Is all the data stored on the cloud, or do we need or do we need a local repository for real-time data and analytics?
Well, obviously,
Yeah, sorry, Steve,
yeah.
it's you, sorry.
Okay, I was gonna say, well, obviously, if you're doing local analytics, not doing analytics in the cloud, you would want to be storing that data locally. And I'm not even going to begin to act like I know as a consultant which kind of data storage to go with for that. But between that and then the if you are wanting to send the real-time data across the network to the cloud, to use that publish subscribe type mechanism, so you're only sending updates as opposed to the unnecessary chatter of back and forth. That's my answer.
Great, and let's move on to you, Brian.
Yeah, absolutely. I think it's the short answer. If you just think about it conceptually, you want to have some sort of data store. Could just be caching that. So again, with those gliders, when they're underwater for days at a time, they're just collecting data. When it comes up, it's got to push all that data up. But typically it's more than a cache. You're doing some sort of local analysis, aggregation, summarization of that data before it goes to its final destination somewhere in the cloud.
And Angel, do you want to give this one a crack?
Absolutely. So yeah, I think yeah, if you're implementing a tool to kind of help, with your IoT infrastructure and making it efficient, you definitely have to store some data locally. Like Brian said, a cache is probably enough. But I've seen situations in more of I want to say, careful here, a government type of application where, they want that raw data as well. So the bottlenecks are the protocols for communication. And then there's issues like, okay, you have, let's say, all these sensors, sending this data. If they're hitting an edge service, that's really helpful because you can store all that stuff there and then slowly, send that information as the protocols allow, or the bottlenecks, right? So the bandwidth maybe, gets choked up, so you can throttle that as well. So there's a lot of applications, but definitely keep that data local as much as you can. Also, if you lose connection, right, connectivity, once that's reestablished, that edge service can start throwing that data back.
Yeah, I mean, I all those were great answers. I think that here, this is kind of one of those things where there's just so many kind of ways to address this.
Yeah.
And when I was talking at the beginning, giving that little bit of a history lesson, we talk about all this data that's being collected at the edge, at the endpoint, right? And, in a lot of ways, it's kind of like trying to avoid storage in some cases and to avoid how much data gets streamed up into the cloud. You can have a device. I just saw a really cool device that was created about hearing what's happening in the Amazon rainforest, because you have so much noise out there, but specifically what a chainsaw sounds like. Specifically what a gunshot sounds like. And so you can have a device sleeping out in the rainforest, just listening for a gunshot or a chainsaw or maybe a big tractor. And it doesn't send any of the other sounds, but as soon as it hears that one sound, it activates and then start sending data, right? And so these are kind of those things, those solutions that you think about at the edge. You can't hear a tractor on, you can't see a tractor on the other side of a mountain, but you can hear it. You can't see a person firing a gun through the rainforest, but you can hear it. And so these are kind of like these edge solutions that people are thinking about, finding ways to kind of mitigate the amount of storage you need, the amount of compute you need at the edge to do these really cool things. Very nice, very nice. All right, so let's see, on to the next one here. We'll go with another one for you, Steve. What do you feel is the biggest threat to the success of IoT at the edge?
I would say that is probably people looking to do it yourself. I'd mentioned that before. So there's just a lot of considerations in regards to marching to the edge, as we say. And if you think that you have all the answers, you're smarter than I am. But that's not saying that much. But there's all kinds of technology out there. People are already, like you just mentioned, great examples of like people already solving all these interesting problems and everything. Why recreate the wheel yourself? Like focus on your operations, your efficiencies, what you're good at, and then bring in a consultant like SpinDance or whoever to say, hey, we've been here before. Here's some gotchas to look out for. Because if you DIY it, you're just going to end up spending a whole lot of money that you didn't need to, and then you're going to have to support it moving forward. COTS, commercially off-the-shelf solutions, are definitely going to be. I propose that you go that route as opposed to DIY.
I throw this quote out too often now at this point, but what is it? Isaac Newton's quote on I would not have seen further had I would not see further, not standing on the shoulders of giants, something like that. It goes, I butchered it. But anyways, does anyone else want to give a crack at that one? Because that is, I threw it at Kepware, at Steve from Kepware, but I feel that that's kind of a pretty general question if someone else wants to go for it. Any other threats to the success of IoT at the edge? If you want to go for it there, Brian or Angel? Okay, Angel, go ahead.
Okay. Oh.
No, go ahead, Brian. Go ahead.
Yeah, I would echo what Steve said. I think it's this weird situation because you definitely want to leverage the experience of others and specialists, and there's a lot of these are solved problems. You were just mentioning hearing things in the Amazon. We had one of our engineers threw together in an afternoon a machine learning model to distinguish between the barks of his two dogs. And he deployed it to his house. So we knew which dog had to go out. Totally just a toy project, but he did that in an afternoon. So you want to be able to leverage those things, but I think there's that balance of really incorporating IoT knowledge and that experience inside the organization. And so we see a lot of people making bad decisions just because they don't know what they don't know. So at some point you got to leverage the experts, but you got to have to grow that capability in-house as well.
Great, yeah, and it looks like Angel, you also wanted to chime in on that one.
Yeah, I got an opinion on it. So I think that what Steve and Brian are talking about, the DIYers, I'm a big hacker, so I hack with the best of them, especially with ARM devices. And but I think the bigger overall, for me at least, is security, right? So these devices are deployed in areas where, it could be a jungle, it could be just in a farm somewhere, wherever, but that data is very valuable and it's very susceptible to, physical threats. Not only maybe a bad actor trying to, scam the system and get some information, but animals, right? So I saw a presentation a couple years ago where in a safari jungle, they were tracking rhinos and using LoRaWAN, and they had these, LoRaWAN interrogators set up throughout the safari, and the baboons were ripping stuff out, right, and basically messing with the equipment. So those were unexpected, things. So again, not only physical security, I'm also talking about encrypting the data at rest, in flight, and then, you know, when it does that round trip back to the edge device or maybe even to the sensor. Security definitely needs to be baked in. And, you know, I think the software developers in general are already kind of at a minimum, you know, clear on security, so they can implement with these new edge devices and the applications that they're going to use. You can kind of build that in, right? And I think somebody mentioned, you know, they deploy hardened Linux operating systems to certain devices, which is true, and that's a good practice right there. But, you know, we need to do better in the transmission and also just overall, right, keeping security kind of at the forefront of all these devices, especially if it's like a mission critical thing. You don't want that data being intercepted, corrupted, or whatever, for obvious reasons, right?
Yeah. Great, good answers there. Appreciate that. I'm so sorry. Time got away from me here. It's already the top of the hour, and I want to let all of our viewers know there are still a few more questions here. So I would like to get through those questions. If our guests are you all good to stay here for a few more extra minutes? Great. So for all the viewers out there, if you want to stick around, we'd love to have you here. You can still post a few more questions in the chat. We'll try to get to them. Otherwise, of course, you'll be able to find this video on demand on IoT Central. So after this, I think within 24 hours to 48 hours or so, you can go find this video uploaded onto the IoT Central website. You can go check all this out later. Thank you for sticking around if you do. All right, cool. So let's knock out a few more of these questions. And I also want to say, you know, we've gotten some cool comments here as well. You know, people in the audience, filtering of data to reduce cloud storage. He's right. LoRa is low bandwidth. And Cellular, get out your checkbook, fellas. Another fella here in the chat here is talking about how he's monitoring the rainforest, but they use drones, IoT of the sky. The Amazon is huge. And then I think addressing one of the points that you mentioned, Steve, consultants are critical for each industrial IoT customer for sure. So there you go.
Can I change my answer on that one, or at least expand on that a little bit? Because Brian brought up a good point too. I don't want to suggest that consultants come in and stick themselves in a conference room and figure everything out for a company. You absolutely need to have operations involved. You know, people need to be involved, and they need to be aligned. They need to be bought into it. They need to be on board. Actually, probably the biggest threat. I'm now completely changing my answer to say that the biggest threat is probably just change management. Getting people to, you know, if it ain't broke, don't fix it mentality of, you know, moving on to something, you know, complete paradigm shift in the architecture of all of this. And, you know, that's something that a lot of people, I think, forego and not think about. But certainly when you get the people of the company who are turning the wrenches and making things happen, if you don't have their insight into what you're trying to do, that it will certainly fail.
Good change. I like that comment. Yeah, I mean, there's a nice mix there. Consultants, you know, my previous company, Lenaro, we did a lot of stuff, you know, what is it? Paid for services, engineering services. So definitely feel you there. One of the questions that came in, it's a pretty blanket question, just came in now, is can we collaborate with you all? So apparently there's someone out there that wants to collaborate with all of you here on the call. I think that's really cool. I'm sure you'll be able to find all of these, all of our guests here. Go check out the on demand. And also we're going to be sharing a slide in just a minute. Not yet. Before we close, you'll get a slide with all of their contact information. So, you know, stick around. You'll get to see that slide or check it out on demand. You'll get all their email information there. So question for you now, Brian, here we go. I have recently been doing several talks on my own live stream, Innovation Coffee, every Thursday, 5 p.m. UTC on the ARM Software Developer YouTube channel. There's my shameless plug. But I got to meet with some folks from TinyML, Pete Warden, and all of those folks from the TinyML Avengers that we call them, working with Edge Impulse and stuff, Google. Do you think that TinyML is ready for prime time? And maybe you can kind of give a little bit of a quick overview, like, you know, just give us a quick little tidbit. What is TinyML? And then do you think it's ready for prime time?
Great question. Yeah, so machine learning is basically it's fancy pattern matching. We'll keep it really generic, right? You're developing sort of model that takes inputs and categorizes it or does something else. So my example of taking audio files from dogs and building a mathematical model essentially that you can then use to understand and discern that. That's machine learning in general. TinyML is taking that and moving it down to a microcontroller. So very, very constrained device without a lot of CPU, without a lot of memory. And the answer is, yeah, it's absolutely ready for prime time if you use it in the right spot, right? Sometimes these models, these mathematical things, these massive 2-3D arrays of a bunch of numbers, they look like gobbledygook, they totally fit into a constrained microcontroller. There's other times where they totally don't. So for example, to use your example, again, Robert, of the Amazon rainforest, if you're just listening for, guns, or you're listening for a particular sound, you could probably build a model, deploy it, and just listen for that one thing. Now, if you want to have a model that listens for 1,000 things, that's probably not going to fit onto a little tiny microcontroller. And that's where a larger, full-blown dedicated piece of hardware would be the way to go. And if you're listening for millions of things, totally not going to work, even in the edge device. That's where you're going to be recording some of the samples and sending it up to the cloud for further processing.
That's great. Great answer. Yeah. And for all of you watching, if TinyML is a new term for you, just go Google search it. You'll find a whole bunch of amazing resources out there. You can go check out hashtag TinyML on Twitter. You'll find all of the people who are chatting about it and talking about it, the experts out there. Definitely a buzzword right now, and lots of cool stuff, developments happening around it. So Steve, let's bring this back to you for a second. I still have a few more questions. I think we have a little bit more time here. So here we go. Did Kepware PTC come up with a different licensing and packaging strategy for ThingWorx Kepware Edge, distributed versus centralized architecture?
Yeah. So whoever is familiar with our licensing, when you think about that one server in the closet in Houston, like I was talking about, communicating to thousands of devices, that's an expensive server, let's just say, in relation to each individual mini server being out there actually at the well site collecting data locally. So the answer is yes, we did change our licensing model to accommodate that change. It's more based on throughput at each individual site as opposed to the massive throughput of that one server.
When I was watching your presentation, the first thing that comes to mind when I was seeing, okay, well, here's the centralized model, and then what we've done is we've taken it, we've decentralized it. I start thinking blockchain, right? Like blockchain, all these different nodes. Well, one node goes down, it's okay because you have a bunch of other nodes. Another thing that pops into my mind, obviously, is Kubernetes, right? You have all these different nodes running, and one goes down. Well, then it just pushes the model over to the other nodes. So, I mean, was there any influence there? Did blockchain have an influence there? You've been around for much longer. Maybe blockchain got influence from you.
Yeah, that is definitely not the case. But I mean, the concept of the distributed, data collection is something a consultant in the industry actually brought to me probably 10 years ago. No, it was just an idea at the time, and it's taken a long time to get there. We're still lots of work to get done to truly get there. Like you mentioned, like if one goes down, the other one comes on board. I mean, there's all kinds of redundancy strategies and uptime and so forth to accommodate for all that, and Kubernetes, being able to deploy at scale. But I don't know how long the blockchain concept has been around. Probably, I'm sure the idea has been around for just as long, but not related at all, but good question.
Thanks. Yeah, huge fan of blockchain tech. Here we go. So now back to you, Brian. We got you this one. You mentioned event-driven architectures. Okay, I think I know what you're talking about, but maybe other people don't. So let's talk about event-driven architectures. Can you give a little high-level explanation of what that is?
Yeah, that would be great. So for a lot of programming models, you think of your smartphone, right? There's like a direct connection between the input and the output, right? You touch the screen, it does something, and you see that on your screen right away. That's an example of a kind of synchronous computing model. Event-driven architecture is where they're asynchronous, right? So I might touch the screen and I get no response. Now that's stupid when we're talking about a GUI because you want that responsiveness. But with a lot of data collection, we don't need that acknowledgement right away. So we're collecting data, we're sending it up to the edge, it's further processed, and we send it up to the cloud. Event-driven architectures really allow us to decouple a lot of that feedback loop and to better process data and ship it. So for example, Kafka, Apache Kafka is an open source tool, all built around kind of a pub sub event-driven model. And that type of model is becoming much more important in the enterprise because there's so many of these enterprise systems generating so much data and they all want to listen to it. So you might have a producer generate some data and it goes into a general kind of broker, and then it, not an MQTT broker, but the same kind of model, and then it gets distributed out to multiple systems. That same principle is a very good fit for a lot of IoT use cases.
Excellent. Thank you, Brian. Appreciate that explanation there. So let's go with one more question here. I think, gosh, I wish I had one more question that covered all three of you, but I don't. So let's just go with one more for you, Steve. Sorry, Angel, we're leaving you on the sidelines here. But yeah, all right, cool. This is our last question of the show. Here we go. This one's for you, Steve. Why are there only 4 edge hardware partners for Kepware?
Man, it was just starting to cut out there. Repeat the question again. I'm sorry.
That's all right. That's all right. You know what? I'm actually, let me see the edge apply. Yeah, there we go. So this question came in. It says, why are there only 4 edge hardware partners for Kepware?
Oh, yeah. I kind of mentioned this, I guess, but there's many that the paperwork needs to get addressed and signed and make sure everyone's kosher with that. And some of these are big companies where, and you know, PTC is a big company too, where, you know, getting the legal process taken care of. But trust me, there's certainly many waiting in the wings. And there's a small little test that they have to run as well. So they just need to allocate the resources to do that. But yeah, the idea is that, like, you know, all the various hardware partners that are in the industrial space will eventually be on that web page for our customers to choose from.
Excellent. All right. Well, thank you very much. I want to, you know, first of all, thank all of our viewers who joined us. You all are amazing. Thank you for spending this valuable time with us. We know it's valuable for everyone. Thank you to our guests. We had Angel Rivera, Senior Developer Advocate for CircleCI, Steve Sponseller, Senior Director, Business Development in America's Channel for Kepware at PTC, and Brian Toll, last but not least, VP of Engineering at SpinDance. Right below me here, you can see all of their contact information. Make sure you take a screenshot. If you don't get it now, you can always check it on demand at IoT Central website. Thank you once again. All right, my name was Robert Wolff. Hope you enjoyed the show. Handing it over to you, back to the folks, David over there at IoT Central. Hope you have a nice day, everyone.
Robert, thank you. That was excellent. And thank you, Angel, Steve, and Brian. As a reminder, a recording of this roundtable will be available for viewing on iotcentral.io by tomorrow. Be sure to look for more webinars and roundtables from IoT Central. This concludes today's roundtable. Thank you for attending.
Guess we drop off.